Now, if you don't feel comfortable using a scientific calculator to calculate the Roche limit, I'm going to show you how you can do it here in Google Calculator. Okay, so there's no excuses for not being able to do this calculation. So to calculate the Roche limit of a planet, the distance where if you get too close, things start to get shredded apart, we have to take 2.4, so you type in 2.4, times the radius of the planet. So if I'm using the radius of Saturn is 5.8 times 10 to the 4 kilometers. So I'll type in 5.8, and then you click this button that says EXP. That gives me the E, big letter E, which represents times 10 to the, and then I say 4. Okay, so I put it in parentheses here. So the radius of Saturn, 5.8 times 10 to the 4 kilometers. To put that into scientific notation into a calculator, you would type 5.8, use this EXP button to give you this big E, and then say 4. And this means 5.8 times 10 to the 4, okay? And then you don't really need to put parentheses around it, but I did here. And then we have to multiply it by the ratio of the density of the planet to the density of this moon or object or planetesimal that's trying to get a little bit too close to the planet. So you have to multiply this by the ratio of, let's say, the density of Saturn, which was 0.7 grams per cubic centimeter. And then we're going to divide it by, so I click the division sign. You can click it here, or I just typed it on my computer keyboard, and divide it by the density of the moon. So Saturn's moons are mostly icy, rocky bodies. And so that density of those materials is about 1.2 grams per cubic centimeter on average. Okay, so this is 0.7 divided by 1.2. We have to take that ratio and we have to raise it to the power of 1/3. How do I do that? Well, if you come over here and you see this button that says x to the power of y, if I click that, it's going to take whatever I put in this parentheses right here and raise it to whatever power I input. So raise it to the power of 1 divided by 3, 1/3. I'm just going to say that that's equal to 0.33. Okay, 1/3 is 0.333 repeating, right, or 0.3 repeating. But I'm just going to approximate that as 1/3. So this is our equation for a Roche limit of a moon around Saturn. We've got to take 2.4 times the radius of the planet times the ratio of the density of the planet to the density of that moon or asteroid that's getting a little bit too close to the planet, and then you raise that to the power of 1/3. So here I raised it to 0.33. Okay, remember, you put the parentheses around that ratio, click this x to the power of y button here to give me the little exponent, and then I can type in the 0.33. Okay, so I'm going to ask you to find the Roche limit around the Earth or some other planet. Okay, if I asked you to find the Roche limit around some other planet, you would change the radius here to the radius of that planet, change this first density here to the density of that planet, change the second density here to the density of whatever object is going to get a little bit too close to that planet and get ripped apart, and then you raise that all to the power of 1/3. Okay, so once we've got it typed in like this, you hit enter, and then that tells us that the Roche limit of Saturn is 116,500 kilometers. So if you get too close in to Saturn, you get closer in than that value, then Saturn's gravity will start ripping you apart.